All right, we're going to get started here with chapter sections 11.7 and 11.8, where we look at permutations and combinations. I have the equations, the formulas written out for them right there, but we're going to talk about them first. So a permutation is basically an ordered arrangement. Note the word ordered, arrangement of a given set or objects, whereas a combination is basically a set or a group or whatever without regard to order. So without regard to order. So basically one of them is an ordered set and the other is the order doesn't matter. So think of a permutation would be like, I know they call them combination locks, but they have to be put in the right order. If your combination is 1, 2, 3, 4, then you have to put it in that order. You have to put 1, 2, 3, 4. You can't put 4, 3, 2, 1. That's not going to work. So combination locks, I think, really should be called permutation locks, but whatever. Order matters. But combinations, on the other hand, order doesn't matter. So if this like might be the members of a team, it doesn't matter what order you list the members of the team. It's still the same team, even if you shuffle the order at which you're just listing their names out. Okay, it's still the same team. For calculating permutations, we will have something that looks like this, where you are essentially going to have n number of things to choose from. So you're choosing from n, and you're choosing r of them. So you have n number of things, and you're choosing r number of them. That's what's going on there, actually with both the combinations and the permutations. And so that's basically going to tell you how many different ways you can arrange them where order matters. And then for combinations, it's almost the same formula, except we have this divided by r factorial. This essentially removes all of our orders that have the same members but are just in a different order. So it's going to count them all only once instead of multiple times. So if I have over here, if I have, if I'm saying, I can have 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So I have all these here. This is the permutations. But how many combinations are there of 1, 2, 3? There's one. 1, 2, 3. It's always just that same group. So we have 6 permutations over here, but only one combination over here of that. So that's the difference between those two. Order matters on permutations. Order doesn't matter on combinations. All right, so let's take a look here. We have these things here, these exclamation points. You can see them up here. They're called factorials. And basically, if you have n factorial, you're doing n times n minus 1 times n minus 2 times n minus 3 times all the way down to times 1. And you just keep going all the way down. So something like 5 factorial would be 5 times 4 times 3 times 2 times 1, like that. And then, of course, there's one other situation where if you have 0 factorial, that actually equals 1 as well. So 0 factorial equals 1, 1 factorial equals 1, 2 factorial equals 2 times 1, that's 2, 3 factorial equals 3 times 2 times 1, that's a 6, and so on and so forth like that. Those are what the factorials do. So let's go ahead and try this here with a calculator. Some calculators will have a factorial button. Other ones you'd have to go through and actually do 6 times 5 times 4 times 3 times 2. And you can do the times 1, but it's always, you can kind of ignore it if you want because it's just times 1. But if you go through and do that here, I'll do that real quick. You have 6 times 5 and then times 4. So 6 times 5 times 4 times 3 times 2 times 1. And that should give you 720. All right, so you can try some of those here. Now we're going to practice with these permutations. So here we have 5 things to choose from, and we're going to pick 2 of them. So if you think about this in the old way when we did the counting up the probabilities and we counted up the number of ways something could occur, we did this as we would say, all right, our first choice, we can pick 5 things. All right, this is without without putting it back in, right? So we're keeping it out once we make the choice. So I have 5 things on the first one, and then I have 4 choices on the second one. So this should equal 20, right? That's our total way. We have 20 ways, 20 different permutations we can do here. And if we try to use the formula instead, we should get the same answer. So this will be 5 factorial over top of 5 minus 2 factorial. So if you look at this, 5 factorial is 5 times 4 times 3 times 2 times 1. And 5 minus 2 factorial, well, that's just a 3 factorial. So this is 3 times 2 times 1. And if you see here, the 3 will cancel with the 3, the 2 will cancel with the 2, the 1 cancels with the 1, and you're left with just 5 times 4, which is what we said just from thinking our way through it, doing it our old way from the probabilities of just coming up with the number of ways that, you know, we could have these arranged. Okay? For this one, we have C, the number of combinations where we're picking 6 of them. So if we have 6 things, number of combinations, we should get 1 here because we're picking all 6. And remember, order doesn't matter. So if there's 6 different marbles in a bag and you pick all 6 out, you're going to have just that one combination. So if we actually try this, we should have 6 factorial, right? That's according to this formula up here. So n is 6, so 6 factorial over top of r factorial, so 6 factorial, times 6 minus 6 factorial. And so you see here, we have 6 factorial over 6 factorial, so those are going to cancel. And then we have 6 minus 6 factorial. So we should have a 1 over a 0 factorial, and 0 factorial is 1. So this is just going to equal 1. Okay? Sorry, I kind of got close to that one. But it's just going to equal 1, which is what we would expect if we picked 6 things out of there. All right, I'm going to do one more, and then I'm going to leave the last ones for you to try here. So here, this time, very similar. We got 6 factorial on top. That's what n is. N is 6. And then r is 2. So we're going to do over that and then 6 minus 2 factorial. All right, so we have 6 things to choose from, and we're going to just count them up. You know, this is going to be 6 times 5 times 4 times 3 times 2 times 1 over top of 6 minus 2 is 4 factorial. So this is 4 times 3 times 2 times 1. Cancels, 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 cancels. 6 times 5 is what we have left, which is 30. All right? And you could have also done that one. So whenever you're doing these permutations, you can do it the old way where we have 6 things where we're picking it without putting it back in, without substitution, right? Or, yeah. And so it would be 6 options for my first choice and 5 options for my second choice. So it would be 6 times 5, which is what we get here, okay? So anytime you do those, it's going to turn out to just be those for the permutations. But the combinations, on the other hand, you have to also divide it by that r factorial. So I'm going to leave it for you to try the rest of the ones on this page, and then you can kind of move on. And, of course, the answers are over here. You can check them. And so, you know, go ahead and check them and see how they go. So next what we're going to do is look here and determine whether or not these things are combinations or permutations. So essentially you're going to look and see, is the order going to matter here, right? So if I look here, it says a photographer wants to arrange 3 children in a row for a family photograph. In how many ways can this be done? Well, if you look at this, order is going to matter because you might have, like the oldest kid, right? And then the middle kid, and then the shortest kid, like the youngest, you might have that as an arrangement. You might do oldest, then youngest, and then the middle one, like that. I mean, you can do different arrangements. You could do the youngest, then the oldest, and then the one in the middle. Like you can, you know what I mean? Each one of those counts. And so order definitely matters here. So this is a permutation. So you're actually asking how many permutations, I forgot to spell that correctly, permutations. So this is a permutation, and you're asking how many permutations can be done. So that's the way you're going to want to do these. So that's what you're looking for. try to go through these and pick them out and decide whether or not they are permutations or combinations. And again, when you're ready, just come over here, and the answers, well, that's still a continuation of that. The answers are all right there. They should tell you permutations or combinations or things like that. All right. Oh, and it looks like they also calculated, sorry, I forgot that part. How many ways can this be done? Well, it's a permutation. So you have 3, and you're choosing. You have 3 choosing 3. So this is a permutation where we have 3 to choose from, and we're picking 3. So that's 3 factorial over 3 minus 3 factorial. So that's just 3 times 2 times 1 over 0 factorial, which is just 1. So this is just 6 right there, okay? So actually go through and do the permutations as well. Okay, after that, we can come over here, and I think we have some more problems here. So for this one, it says, Lauren is going on a cruise. She has 6 sundresses and 14 pairs of shoes she wants to pack. There is only room for 4 sundresses, and 8 pairs of shoes. So how many different outfits can she make? So again, what you're trying to do here is figure out, are they asking you combinations or permutations? And then you're going to try and put these together. So we're going on a cruise. She has 6 sundresses and 14 pairs of shoes. So she can only pick 4 sundresses and 8 pairs of shoes. So when we're combining these together, just like with probabilities, it's going to be find our 2 different permutations. Well, here we don't want permutations, we want combinations, because it really doesn't matter what order she packs the sundresses in. For at least for the ones she's taking, what we're interested in is how many different outfits can be made. And it's not going to matter if it's like, if we pick a sundress, you know, where the order matters here. So if I look at this, I'm going to pick 4 sundresses. So my permutations there is I'm picking 4 out of 6, right? Just like that. And then I'm picking 8 pairs of shoes out of 14 pairs of shoes right there. And then when we want to combine these 2 together, we'll just multiply them together. And so when you go through to do this one, it's going to be 6 factorial over 6 minus 4 factorial. And then we're going to combine them together by just the way we did the countings before with our probabilities. This will be 14 factorial over 14 minus 8 factorial, like that. And so what we'd end up with here is 6 factorial over 2 factorial times 14 factorial over 6 factorial. So 14 minus 8 is 6. So these will actually cancel, and you'll be left with 14 factorial over 2 factorial, which just means you can do 14 factorial and divide it by 2, whatever that happens to be. So don't make it 7 factorial. You don't do that. So this would have to be, 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over top of 2 times 1. And the 2 and the 1s will cancel like that. And then that's what you'd have to multiply out there, okay? Hey, everybody. Sorry, I finished this up and hope it wasn't too confusing. I don't want to re-record the whole thing. But I realized it occurred to me after I left this page, and I maybe should have gone back before I did this, but I put permutations here, and I should have put combinations, because the order doesn't matter, and I think I even said that as I was going through it. I said the other order didn't matter, but then sure enough, I wrote permutation instead of combination. So this should have a 4 factorial under it, and then this should have an 8 factorial under it, like that. And so we should have a 4 factorial and an 8 factorial underneath there. So when you calculate it out, now you should get the actual answer that they had. So anyway, sorry about that, and I'm pretty sure I said order doesn't matter, but then I wrote permutation. So combination is what we wanted there, and I left that part out. So again, we should have had a 4 factorial and an 8 factorial there, like that, and then a 4 factorial over here and an 8 factorial there too. So like that. All right, so there's the corrections to it. So sorry about that. Anyway, that's all again. So I'm going to leave these ones also for you to try, and I may go through some of them when we need to in class. But there were some I wanted to look at. Where were they? So these are all the same. And again, check out the answers here at the end. But where were the ones I was wanting to look at? So these, no, it wasn't there. So these are some more of that. Yeah, let's take a look. Was it these? No. There was, where is it? Okay, it's this one's right here, 11 through 14. These are the ones I wanted to look at. Sorry. So sometimes you have to worry, especially when we get to number 14 here, that sometimes you're going to have indistinguishable things that are repeating, and I'm going to talk about that with number 14. So let's take a look here. A dance recital has 9 routines to showcase. 5 are ballet routines and 4 are jazz routines. Each routine is to be performed only once. How many ways can the routines be arranged? So here, order matters. We're doing all 9 of them, 5 of these and 4 of these, but we can change the order. That's all we can really do. So the order matters. That's a permutation. So what we're looking for is how many different ways can we arrange all 9 of these things. So this will be 9, and we're going to choose 9. So this will be 9 factorial over 9 minus 9 factorial, which is 9 factorial over 0 factorial, which is 0 factorial is just 1. So this is just 9 factorial. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiply those all out, and you should have your answer for that one. Okay? Then it gets a little bit trickier. Now it says the first routine must be ballet and the last routine must be ballet. So that gets a little bit tricky here because the first one has to be ballet and the last one has to be ballet. So for our very first one, we might as well pick them right off the bat. I have 5 ballets to choose from. So my very first one, I have 5 choices. Then for the very last one, I have 4 ballets to pick from. And so after I pick my first ballet and my last ballet, because that's the way I'm going to want to do it. I don't want to pick my first ballet and then randomly pick everything else because I might end up with my very last pick having no ballets left to pick. So I pick my first ballet and I pick my last ballet. So I have 5 to choose from on the first one, 4 to choose from on for the very last one, the one that go at the end. And then I can look at how many ways can I arrange the 7 things that are left. So this would be then times all my number of ways, all my permutations for arranging those last 7. So this would ultimately just be 5 times 4, and then when we're doing this is 7 factorial over 0 factorial, right? Because it'll be 7 over 7 minus 7 factorial. I'll just write it. 7 factorial over 7 minus 7 factorial, like that. So this is just 7 factorial. This is just 5 times 4 times 7 times 6 times 5 times 4 times 3 times 2 times 1, just like that. And again, you don't have to do the times 1, but it is there. All right, now it changes it up a little bit. The first 2 routines must be jazz. So our first jazz is going to be, we have 4 jazz routines. Our second jazz routine is there's 3 jazz routines. And then after that, we're just picking everything again. And this will be, again, we have 7 left and 7 to choose from right there, where we can pick from all the rest that are left. Okay? And again, you can do that one, and I'll leave you to write that one out and calculate it. And then this last one here, this is another little tricky thing. It asks us how many ways can the word Tallahassee be done? But you have to remember, like for example, if we had the word Bob, how many ways can we arrange Bob? Well, if our 2 B's are different, like if it's B, O, B like this, well then that is different than this B, O, B, right? If those B's are different. But if you look at it, the B's are not different. They're indistinguishable. So if they were all just the same color, there was no way to distinguish the B's, then these 2 are actually just one thing. There's only one there. So, for example, if I'm trying to spell the word Tallahassee, if I swap these 2 L's, it's still the same word Tallahassee. It made no difference to it. So we have to be careful here when we have repeating indistinguishable items. And so the way to do this is to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. we have 11 different letters. And so we're not going to, whenever we pick them out, we're not going to put them back in. So I have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Those are all my choices. So I have an 11 factorial. I wanted to go back to this. So I have an 11 factorial there for the number of ways that I can arrange it. But then I have to worry about the arrangements where all I ended up doing was swapping two of the same letters. So if I look at this, I have to figure out how many of the repeating letters I have. If I look here, I have 3 A's. I have 2 L's, right? I have 1, 2, 3 A's. I see 2 L's. I see only 1 H, 1 T, but I have 2 S's. So I have 2 S's, and I have 2 E's. So E's are times 2. And so to get rid of all the possible ways where those ones are just repeating, what you do is divide by the number of ways an individual thing repeats, factorial like that. 2 factorial. Essentially, we're dividing by the number of ways we can arrange those identical letters and removing all the ones that give us duplicate results. And so that would be the answer there for that one. All right, so that's pretty much it for this one, except going through and doing those practice ones. Do those practice ones, do all these ones I didn't do. And if there's any of them you can't do, we'll look at them tomorrow at the start of class. But I wanted to give you all something to go ahead and start working on and be ready for it in class tomorrow. Tomorrow I'll just answer any of these that y'all had questions on you couldn't do, and then we'll begin doing 11.9. But that's it. That's it for 11.8 and 11.7 and 11.8. And hopefully it made some sense for you. All right. Thanks. Bye.